So this bullet point here where we're relating pressure changes to what's happening in a chemical reaction. So the idea here is, let's say you've got something like maybe this decomposition reaction. This is a reaction that may be relevant to you in lab. If you heat, uppercase delta symbols often used to indicate heat this compound up, it can get converted into these products, and so I want to make sure that that's balanced. So now I've got 2 sodiums on both sides, 2 hydrogens, 6 oxygen, so everything should be balanced there. So under the temperature that this reaction is typically performed, these 2 products are gases. This is a solid, and this is a solid. So the question might say something like, starting with this solid in a container, maybe the container's sealed, I've got this solid here, I heat it up, and the pressure changes from maybe the standard 1 atmosphere pressure that the air around that solid would normally have, and it increases to 1.4 atmospheres. Right, so relating a change in pressure to a quantity of reaction that's occurred, how do I do that? Well, the quantity of the reaction that's occurred, or the amount of reaction that has happened, usually measured in moles or grams, but we know the relationship between moles and grams, so either way we can convert between those two. Right? But the idea here is, if I know how many moles of this reacted, that will tell me how much the reaction has occurred. Or if I know how many moles of the products are produced, that will tell me how much the reaction has occurred. And if I have information about pressure, there's a relationship between pressure and moles for gases. That's the ideal gas law. Right, so I'd have to be given information about what this temperature is. I'd have to be given information about the volume of the container. And then this information about the pressure can be used, since we also know R, to determine how many moles of gas have either been created or consumed, depending on the specifics of the reaction. Right? In this reaction, I don't have any gas on the reactant side. I'm only producing gas. So the increase in pressure must be due to the extra gas that was produced, assuming that there's no change in temperature and no change in volume. Right? So if that's the case, so I could solve this type of question. If I'm given a temperature, so we could say, since we're heating it here, maybe the temperature is 450, probably be higher than that. Let's go with like 850 Kelvin. So I'm given the temperature. Let's say the volume of the container is 1 liter. How many moles of gas have been produced? And now I have the information to solve for that. And so I would rearrange the ideal gas law, solving for N. And I would plug in the pressure. So I wouldn't plug in 1 atmosphere or 1.4. I would plug in the change in pressure, right? Because starting with 1 atmosphere, that's just the air that's around in that container. The 1.4 atmospheres after the reaction is the air that was around before, plus the extra molecules of the water and CO2 that are produced that are in the gas phase under those conditions. So it's the difference, the 0.4 atmospheres that should represent the quantity of gas produced. So then I'd plug in the volume, plug in R, plug in the temperature. Hopefully this won't give me a really ridiculous number since I just made these numbers up off the top of my head. So I'd take 0.4 divided by 0.08206 divided by 850, and I get 0.0057. And really, I only have one sig figure because subtracting 1.0 from 1.4, I only have certainty in that one decimal place. So when I multiply and divide, I really only have one sig fig, but I don't want to round till I'm done. So that would tell me how many moles of gas are produced. So if that's the answer, then I would just round it to 0.005 or 0.006 moles. Probably more likely I would be asking how much solid would be consumed. Right? So if I started with 1 gram of the NaHCO3, what should the mass of that be? Or how much will the mass of that go down by? How much of that is reacting? How would I answer that? Yeah, there are a couple ways I could think about that. And once I have a quantity of a substance consumed or a substance produced in moles, then I can use the coefficients in the balanced reaction to relate moles of a substance with moles of a different substance. Right? So the idea here is, if this is based on that increase in pressure of 0.4 atmospheres, this is the moles total of all the gas produced. Half of that is water and half of it is CO2 because they're produced in a 1-to-1 ratio. So if I divide that number by 2, that will tell me how many moles of water are produced. And then the same number divided by 2 will tell me how many moles of CO2 are produced. So then I could take those numbers in moles and convert them to grams. And I know if those are the grams that have been produced in the form of a gas, then they're not part of the solid anymore. That's how much the mass of the solid must have gone down by. That'll be one way to do that. Another way to do it would be to say, I also know this relationship because of this 2 here, and because I've got 1s here and here. I can say one relationship is that there are 2 moles of NaHCO3 that are responsible to produce 2 moles of gas in the end, right? 1 mole of water gas and 1 mole of CO2 gas. Two combined moles of gas come from 2 moles of the NaHCO3 because of the coefficients in the balanced reaction. Right? So that's a 2 to 2, which is the same as a 1 to 1. So that means this number of moles of gas produced must also be equal to the number of moles of NaHCO3 that were consumed. Right? So I could use that in a relationship. I could say, maybe I want to know how many grams of NaHCO3 were consumed. So I would take what I just calculated in moles of gas, total moles of gas produced. I would use this 2-to-2 ratio, 2 moles total of gas for every 2 moles of NaHCO3. Then I would get the molar mass of NaHCO3 and convert it from moles to grams. So I would take 1 sodium, 22.99 plus hydrogen plus a carbon plus 3 oxygen, and I get 84.005 grams of that substance per mole of that substance. So then if I multiply that, I get 0.5 grams. The coefficients relate the substances to one another, right? So these are my products, and the increase in pressure is showing that these are forming, and I have for every 2 moles of these forming, 2 moles of this consumed. That relationship tells me how much of this is actually reacting and being converted into products. So the book actually is a little bit lacking in those types of questions. There are some in Chapter 11 that require you to use a pressure change along with the volume and temperature to figure out how many moles of gas are being produced or consumed. And then you can relate the moles of a substance to moles of another substance in the balanced reaction, and then convert moles to grams.